All right, welcome to the fourth video in the Completing the Square series, and this is where I take off all the kid gloves and training wheels and we just go for it, okay? So the goal here is not to scare you or make things overly complicated, though it might feel that way. The real goal here is to show you that even when the numbers get ugly or weird, the procedure, the step-by-step procedure, the patterns are still the same, okay? So we might do more than 2 examples on this one. So, all right. Oh, sorry, example 1, there we go, okay. So we're going to complete the square this first time on 3x squared plus 4x plus 5. All right, and as always, if you watched the previous video, level 3, this is going to be the same procedure. So if you want to, just go ahead and pause right now and see if you can figure this one out on your own, work through it. Be good experience, good exercise for you. And when you've done that, unpause and come back and watch the rest of this. All right. Go. And you're back. Okay, so every time we complete the square, we need to match the perfect square pattern. And of course, by now, you may not need this actually written out. So I'm only doing this for instructional purposes. I certainly don't need to write it out every time I do it because I'm so familiar with it. So it's not a requirement, it's just a helpful aid in matching things. So here we go. Like on the level 3 video, when we go to match the square terms, we have a problem because the coefficient is not a 1. So we factor it out, and again, I'm only going to factor it out of the first 2 terms. You can factor it out of all 3 terms. It just makes it more complicated. Okay, there's more work to do in that case. All right, so here we go. We're going to factor out the 3. And again, we're only going to factor it out of the first 2 terms. So 3 divided by 3 is 1, and so that leaves behind the x squared. Here, now remember, factoring is division. So when we factor out a 3, this becomes 4 divided by 3. Well, 4 divided by 3 is, well, 4 divided by 3. And then like we did on the last example in the previous video, I'm going to go ahead and write in a +0 for my constant term inside the square brackets. This +5 doesn't go away. It's still right there. So I'll have this +5. The 3 just got factored out. But now we are going to work on completing the square, but only inside the square brackets. So matching up our pattern then inside the square brackets, 1x squared, we match. Then the middle term will match if we make the right definition. 2b times x has to be the 4/3 x. So the 2b has to be the 4/3. Let's come over here and write that down. So our 2b has to be the 4/3. So with that definition, the 2bx matches the 4/3 x. So we match. Now the constant term, this +0, has to be written using b squareds. So we're going to divide. I don't want to write, when I write this as a division, I don't want to write this as 4/3 divided by 2. That looks ugly. So remember, Dividing by 2 is the same as multiplying by 1/2. So if I multiply both sides by 1/2, I'll get b equals 4/3 times 1/2. And so we'll end up with 4/6. But that reduces. So b equals 2/3. So b equals 2/3. We need b squared. So b squared will be equal to 2/3 squared. That's 2 times 2 is 4, and 3 times 3 is 9. So our b squared is 4/9. So we'll write the 0 here using 4/9. Okay, 0 written using 4/9 would be 4/9 minus 4/9. And all of that's inside the square brackets. The plus 5 is still on the outside. Okay. Regrouping on the inside of the square brackets. We want the first 3 terms inside those brackets to be grouped. This 4th term is still inside the square brackets. It's just not invited to the perfect square party. And we double check. And here is 1x squared. Based on our definition, here's 2b times x. And based on our calculations, here is plus b squared, which makes everything inside those parentheses a perfect square. And what do we know about factoring perfect squares? Have this particular form, like this. They always factor into x plus capital B squared. Capital B is equal to 2/3. So these first 3 terms will factor into x plus capital B, which is 2/3, squared. The minus 4/9 is still there, plus 5 on the outside. Now what? Well, we're supposed to combine the constants, but the negative 4/9 is inside the brackets, and everything in the brackets is getting multiplied by 3. So we're going to need to distribute the 3 through the square brackets, not the parentheses, just the square brackets. So we're going to get 3 times the parentheses minus, okay, so 3 times the 4/9. So there's the 3 times the 4/9. It's still negative. And then we still have the plus 5. Now we're going to have to end up combining these. This stuff is going to be a fraction, so we want to think of the 5 as a 5/1. All right, so in getting this, multiplying this, we're going to be multiplying by 3 and dividing by 9. The 3 and the 9 both share a factor of 3. So this 3 will divide out with one of the 3's that makes up the 9. So this ends up being a minus 4/3. Now, if you didn't like that, if you want to see it in more detail, over here real quick, right? 3/1 times 4/9. You can think of that as 3 times 4 is 12/9. But 12 and 9 are both divisible by 3. So 12 divided by 3 is the 4, and the 9 divided by 3 is the 3. Oh, here we go. So it reduces down to the 4/3. The 5 is going to need to combine. We need a common denominator. So let's write that with a common denominator of 3. So the numerator becomes 15. So 15 and a -4 is 11. So we're going to get 11/3. There's our completed square form. All right, let's look at a different example. So let's complete the square on -4x squared plus, sorry, lost my train of thought there for a moment, plus 10x. 10x, oh, let's do something more fun than that. Yeah, let's do a 9x. Oh, I like that, 9x. Can you read that? -6. I don't know, just making it up. All right, that looks a little messy. Let me rewrite it for you. -4x squared plus 9x minus 6. All right, there we go. That's what we'll work with. We're going to complete the square. So, like I've been recommending, why don't you hit pause, see if you can play with it for a little bit on your own, and then come back and see how I work it out, see if you can spot any errors that I make. Hopefully not. Okay, and you're back. So we're completing the square. We know we have to work with the pattern, x squared plus 2 times bx plus b squared. And as we've been seeing, when we start to match up the pattern, the leading coefficient is not a 1. So we're going to need to fix that. The way we fix it is by factoring it out. So just going to factor it out of the first 2 terms. So we factor out the -4. And so -4 divided by -4 is a 1, leaving behind x squared. Now, this next one is a +9 divided by a -4. Positive divided by a negative is negative, so we get negative. And 9 divided by 4 is, well, 9 divided by 4. And then we're keeping the -6 outside of the square brackets. So inside the square brackets, the constant will be a +0. There's our -6. And now we work inside the square brackets. So x squareds match. The middle term, we know that we need to take the 2b and set it equal to the coefficient here, which includes the minus sign. So we're going to, let's come over here, we're going to state that 2b has to be the -9/4. And multiplying both sides by 1/2, it gives us -9/4 times 1/2. That's a -9/8. So now b squared is negative times negative is positive. 9 times 9 is 81. 8 times 8 is 64. So we will use the b squared to rewrite the 0. So -4, the x squared minus 9/4 x plus, we'll have 81/64 minus 81/64. The -6 is still on the outside. Now, I know I haven't written it in a regrouped form, but that's really just a nicety. We know that it's going to be those first three terms. Those first three terms together form a perfect square. And so we know that those first three terms will automatically factor into x plus b, and our b value is a -9/8. We still have the minus 81/64 and the -6 on the outside. We multiply through the square braces, not through the parentheses. We cannot multiply through the parentheses because of the square. Order of operations, remember? You cannot do the multiplication before you take care of the exponent. So we multiply onto, but not into. But we do take the -4 times the -81/64. Well, negative times negative gives you a positive. And so we'll have 4/1 times 81/64. We still have the -6. 4 and 64, they're both divisible by 4. So we can reduce those. So this becomes 16 down here. So we have -4 times the x minus 9/8, the quantity x minus 9/8 squared, plus the numerator is 81, the denominator is 16, and now we've got to combine it with this 6/1. All right, so just a little bit of fun with the fractions. We need to convert the 6/1 into a fraction with a denominator of 16. So the numerator is going to have to be 6 times 16. So that's what? 6 times 10 is 60, 36, 96. There we go. Double check my math. Tell me if I got it wrong. So positive 81, negative 96. That's going to be negative, that's what, 6 and 9, 15. And as long as I did the arithmetic in my head correctly, that should be the completed square form. All right, so I'm going to do another example here. This time, we're going to complete the square on 2/3 x squared minus 17x plus 4. All right, we know that we have to match up with the perfect square form. And so we start like we did before with factoring out the leading coefficient from the first two terms. So we factor out the 2/3. So 2/3 factored out leaves behind the 1x squared that we wanted. And here we have negative 17 divided by 2/3. All right, well, we're going to come over here and play with that for a minute. Okay, so we have negative 17 divided by 2/3. When you divide by a fraction, that's the same as multiplying by the reciprocal. Right? We flip the fraction upside down. This is negative 17 over 1 times 3 over 2, which is negative 51. 17 times 3 is 51. 1 times 2 is 2, so we get a negative 51 halves. So the middle term becomes negative 51 over 2 times x. We'll put a 0 in there for the constant. And the plus 4 is on the outside. All right, so the x squared terms match. Now we need to make our definition, so the x terms match. So to do that, we will define 2b to be equal to, remember, that even when I write it sloppy, you have to keep the sign with the coefficient. So 2b is equal to a negative 51 over 2. And since we made that definition, the x terms match. Now we need to rewrite the 0. So we need b squared. So we're going to find b first. Multiply both sides by 1/2. And we will see that b is equal to a negative 51 over 4 when we get done with that. And b squared then is negative 51 fourths multiplied by itself gives us, well, negative times negative is positive. And well, in the denominator, 4 times 4 is 16. And in the numerator, 51 times 51 is, well, I'll tell you what, let's just call it 51 squared for a moment. Let's deal with that later, okay? All right, good idea. All right. Point here is that I'm avoiding doing extra work right now because I hope that maybe something will simplify and it will be easier. I could be wrong, but I can square the 51 later just as easily as squaring it right now. So because it's kind of big, I'm going to leave it alone. Okay, so let's see. 2/3 square brackets x squared minus 51 over 2 times x plus, write the 0 using the b squareds, so that will be a 51 squared over 16 minus a 51 squared over 16. Close the square brackets, put that plus 4 on the outside. First 3 terms are a perfect square, so we know that they will factor. They factor into x plus b. Our b value is a negative 51 over 4, so x plus a negative 51 over 4. That's the first 3 terms. We still have the minus 51 squared over 16. Close the square brackets. Still have the plus 4. The numbers are kind of big and ugly this time, but I hope that you're recognizing that the step-by-step procedure is the same. The patterns are the same. It's just the numbers are uglier. We multiply through the brackets. So we get 2/3 times the parentheses minus, so 2/3 times a negative stuff, that will be minus. We'll have 2/3 times the 51 squared over 16. We'll still have the plus 4. Well, let's see here. Let's come over here and play with these fractions a little bit. It's a little scrap work off to the side here. Okay, so 2/3 times 51 times 51 divided by the 16. So this is the 2 and the 16 will reduce. And now, do you remember where we got the 51 from? If we go all the way back up to the top of our sidebar here, we got the 51 because we multiplied 17 times 3. That means one of these 51s we can write as a 17 times 3. So let's see, this would then be, let's do this one. Write that one as write it as a 3 times 17. And so what we have now is we got rid of that 2, so it's a 1/3 times a 3 times a 17 times a 51 over the 16 reduced down to an 8. So if we're going to multiply by 3 and divide by 3, that undoes it, and we're left with 17 times 51 over 8. But should be putting some equal signs on there. We already said the 51 was 3 times 17, so this is really 17 times 17 times 3 over 8. That's 17 squared. Oh, that's not so bad. You guys remember what 17 squared is? Did you get 349? No. Yes. No. Yes. I should stop trying to do it in my head, but it's too much fun. All right, you guys have already done it on your calculator and you're sitting there being bored. So somebody just shout it out for me. What is it? All right, hold on. My brain is dead. Oh. All right. $289 times 3 over 8. So let's see here. 3 times 200 is 600. 3 times 80 is 240. 3 times 9 is 27. So it's what? 840, 60, 867 over 8. Ah, okay. And it was going to be negative. Sorry about that. Just goes to show. So we get negative 867 over 8. I'm going to be embarrassed if there's a mistake in that calculation. And we need to add the 4 onto it. So think of the 4 over 1. So get it to a common denominator. So let's see, 8:35. By the way, just the fact that I paused there and I could easily have made an arithmetic error in here somewhere on one of these videos. Oh, did I not show all of that to you? Sorry, guys. Um, right, I'm making a lot of these problems up just on the fly. That is, I'm not designing them ahead of time so they work out nicely or something. Uh, I don't have the solutions already written out. So anyway, I hope that doesn't bother you, but I also hope that you see the value in actually watching and listening to me work through the stuff, not knowing what the outcome is going to be ahead of time. At any rate, um, so this is the end of this particular video. The next video will be the how do you do this super fast.